There are still a lot of unknowns in the universe. I think we're going to find all sorts of phenomena that we never dreamt of when we start exploring that dimension.
In terms of the distances that LOFAR probes, it basically probes all the way basically to nearly at the Big Bang. The whole universe on every distance scale will be probed by LOFAR.
LOFAR is a radio telescope, which means it's set up to detect waves coming from the sky, radio waves, which are like light but are much lower energy waves coming from lower energy sources in the sky. We're standing in the middle of farm fields in Hampshire in a place called Chilbolton, which is a little village. It was set up with a radio astronomy dish, which you can see behind me. What we're using it for here for LOFAR is because it is a site fairly remote from towns, even though it's in a pretty populated area, it doesn't have much radio interference, and that makes it a good place to look up for radio waves coming from the sky. What you see here, of course, is only a small fraction of LOFAR, which includes many other similar installations across Europe, and the installation in Holland, which is the center of the array, is much, much larger.
If it were a single dish, at the lowest frequencies this telescope would be approaching a kilometre across, a little bit less than a kilometre across. So that's an enormous amount of collecting area. These days, with the advances in computing technology and data transport, we're able to capture all of the signals that the antennae are collecting and transport them and put them all together and combine them in real time. In the past, the technology which we had for the antennae was about the same, in fact, but you were only able to recover a tiny fraction of the information that was being detected. So it's really the advance in computing and the internet that's allowed us to make these advances forward.
The sciences that we're trying to do with this is detect radio waves which have been traveling extremely long distances across the universe. They've been traveling for 12 billion years out of the 13 billion years that the universe has existed. And that means we can look back to a time before there were even stars with this kind of instrument.
One of the key initial goals for LOFAR was to look for this thing called the epoch of reionization. And the idea is that more than 10 billion years ago, the universe went from a cold state to a hot state. And actually, this is a major step in the evolution of the universe, and yet we don't know exactly how and when it happened. So LOFAR should be able to probe all the way back to shortly after the Big Bang and find out about this.